Okay, so we're going to start with understanding a little bit about what MakerBot is. This is a company that produces 3D printers. At Venture Robotics, we do have one of these MakerBots and are currently in the learning stages of all that it can do. So we're going to learn a little bit about the role that MakerBot had in a 3D printing for an amazing telescope, and then we're going to look at some of that telescope.
As the founder of the desktop 3D printing initiative here at the ATC, I was lucky enough to actually have my Replicator 2 in my cube with me. In the first quarter alone, I was able to print over 250 distinct parts for various programs. And what you see here today for James Webb is really just one of those programs.
The James Webb Space Telescope is NASA's biggest science mission ever. It's going to be the largest space telescope that's ever been launched. And so the pictures that we expect from James Webb will change our understanding of the universe and be much more spectacular than anything we have ever seen before.
Having the MakerBot on our desktops has really allowed us to bring rapid prototyping within the design cycle here at the Advanced Technology Center. We've used rapid prototyping for years, but invariably it involves outsourcing parts to machine shops. This allows us to quickly go from conceptual design to CAD model to 3D printed part, and to really see and measure how that part interacts with the real world. And in the end, it allows us to produce better designs faster.
In particular, 3D printing has really played a role here for us in allowing us to develop products up front, find potential mistakes, optimize very early in the design process. That has been very, very beneficial.
James Webb Space Telescope is going to operate 1.5 million kilometers away from Earth. So we use the MakerBot parts to test our processes and to make sure that it was done right the first time.
So it also allowed us to work in parallel. So while we were developing some of the parts that were going to go into the instrument itself was in a cryo vacuum chamber, and it was going along with its cryo testing while we were developing these prototypes with the MakerBot, which allowed.
All right, let's look at what the James Webb Telescope looks like and what it's about.
I don't think it is very useful to speculate on what God might or might not be able to do. Rather, we should examine what he actually does with the universe we live in.
This is the telescope that you're seeing.
All our observations suggest that it operates according to well-defined laws. These laws may have been ordained by God, but it seems that he does not intervene in the universe to break the laws, at least, not once he had set the universe going.
In the cauldron of the early universe, no light could escape the dense, opaque fog of primordial gas. As this cosmic soup of atomic particles began to cool down, hydrogen atoms began to form, leading to the universe's first bright, violent new stars, burning through the fog that once blocked all light from escaping the expanding universe. Some of these early photons have traveled unhindered through the vast, empty expanse of space for 13.5 billion years, and will reach their final destination here on the man-made detectors of the James Webb Telescope. A space odyssey coming to an end because of the curiosity of humans. The James Webb Telescope is going to give us our first detailed glimpse of this early universe from which we and everything we know was born. The James Webb Telescope is a $10 billion endeavor, an endeavor that has eaten into NASA's limited budget, consuming 1/4 of NASA's entire astronomy budget for years. And in the early hours of a tenuous launch date of December 24th, this $10 billion gamble will launch aboard the Ariane 5 rocket, a European heavy lift launch vehicle from the European spaceport in Kourou, French Guiana. Astronomers, physicists, and enthusiasts alike will look on with nervous excitement as this rocket carries the next generation in human curiosity.
All right, so let's take a look at this rocket launching and how that came through.
liftoff from a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe.
A Christmas launch from South America. The new $10 billion James Webb Space Telescope, the ultimate holiday light display.
Go Webb!
Moments later, real-time images with the telescope making its way into deep space.
Now taking its first steps in pursuit of cosmological discovery.
It now begins a 2-week process to deploy its antennas, mirrors, and sunshield.
James Webb now has its array out.
It is 100 times more powerful than the Hubble telescope before it, and will...
When they talk about deploying, don't you think that there are methods of robotics involved with that?
will orbit the sun nearly 1 million miles away from Earth. Scientists will get a deeper look into the universe, capturing light so far that the lens will show images of what happened 13 billion years into the past, maybe even from the beginning of the universe.
We are going to discover incredible things that we never imagined.
The new 7-ton telescope will also expand the search for Earth-like planets with elements that make life possible. Thousands of people from 14 countries worked on the project for more than 2 decades, and it'll be another 6 months before it is fully operational. But today, celebrations after a successful launch.
We have delivered a Christmas gift today to humanity.
A gift of knowledge, perhaps unwrapping unimaginable secrets from across time and space. Guad Venegas, NBC News, Planet Earth.
Planet Earth. Okay, so we just wanted to give you guys a glimpse of how 3D printing can be involved, and hopefully we can do a little bit more videos on the role of robotics within this program.